In a certain hospital, the data shown to the right was recorded. Use a Venn diagram to answer parts A through H about the blood samples. For parts D through H, the presence or absence of antigens determines blood type. In order to fully understand how to do this problem, you first need to understand that there are 8 blood types that we're going to be talking about. Now, there are more than that depending upon other antigens, but right now we're concerned with 3 primary antigens, A, B, and RH. Now, the RH factor will determine if the blood type is positive or negative. So, using this information, we're going to label and discuss how many blood types there are. We will have A, and if RH is present, so that means that A is present, and RH is present, and that will give us a blood type that is A positive. If RH is negative, and I should say if RH is not present, that will give us A negative blood. Now, if B is present, we have 2 options. RH is present and RH is not present. So if RH is present, then we will be looking at B positive. If RH is not present, then we're looking at B negative. Then we have the option of having both A and B being present. And once again, we will have the option of RH being present and RH being not present. If RH is not present, or I should say if RH is present, that's AB positive. If RH is not present, that is AB negative. Then finally, we have the choice of A and B. That means both of them not being present. And the way I've written it, A and or B not present, means that neither of them really are not going to be present for this following blood type. Once again, RH will either be present or RH will not be present. If A and B are not present and RH is present, that will be O positive blood. If A and B are not present and RH is not present, that is O negative blood. Now we want to use this in a Venn diagram in order to answer the questions in the problem. So let's go ahead and set up a Venn diagram. Okay, here's our Venn diagram. Remember that A is going to represent the presence of the A antigen, B will represent the presence of the B antigen, RH will represent the presence of the RH antigen. Which means that if we're looking at the absence of the A antigen, we would be looking at everything that is outside the red circle. And let me illustrate what that would look like. This is going to be the absence of the A antigen. Oops. So it's everything outside the red circle. Okay, and likewise we could do the same thing for the absence of the B antigen would be everything outside the purple circle, and the absence of the RH antigen would be everything outside of the blue circle. So let's talk about how we're going to arrange numbers inside the circles here. We need to remember that anything outside of all 3 of the circles will be considered the universal set. And since that's outside of A, B, and RH, that means that we will be looking at O negative being outside of the 3 circles. But we'll talk about that in a moment. Now, let's look at this one at the bottom. And we're always going to start at the bottom, and we're going to work our way up. So the first thing that we're going to look at is right here. This is A, B, and RH. That's going to be the intersection of all 3 sets. And if that's the intersection of all 3 sets, that means that we're looking at this area right in here that I am outlining. And that means that we would put this number 4 right here in the middle. Okay? So let's tidy that up, and I'm going to color in that area. And this is going to represent the intersection of the 3 sets. And we're going to go ahead and put in the number 4. And that represents the fact that this right here is going to be AB positive because A is present, B is present, and the RH is present. So we will go ahead and let that be known as AB positive. And we now know that there are 4 patients here that have AB positive blood. So then we're going to move to the next one in the list. This will be number 2, or the second thing that we're going to do. This is going to be A and RH. Now A and RH is going to be this circle where A and RH, or I should say area where A and RH intersect. And notice that that's going to be this area right here and also that area. But remember, we've already discussed this area. So there are 4 people in that group. And this entire light blue area is going to be made up of 31 people. But we already have 4 people accounted for. So this will be 31 minus 4, which will be equal to 27. So we need to go ahead and put that value in right here. Now, what does that mean? Well, that means that these are A positive individuals because the A is present and the RH is present. Now we move on to the next one. And notice that we're just going to keep on climbing up the ranks here. Now this right here says there are none that have antigens in the blood. That means that there's no A, no B, and no RH. And that is going to be this area right here that is outside of the A, the B, and the RH. And so that would be 12 individuals that exist outside that area. And so we'll put that there. And remember what I said, that if A is not present, B is not present, and RH is not present, that is going to represent O negative blood. Now we move on and we look at RH is present. Well, that's going to be this blue circle, but notice that there's an area inside the blue circle that I haven't filled in yet with a number that is also part of an intersection. And since this blue number 27 indicated the presence of A and the presence of RH but not of B, this area right here in gray will represent the presence of B and the presence of RH but not A. And notice that if we move up the list just one more, we will be looking at this one right here. And this is the one we're going to do fourth, B and RH. And since we already have 4 people, the B and RH will be 11 minus 4, which will be equal to 7. So we will put 7 right there. Now, since we filled in this area and this area, it follows that we should fill in this area. And notice that that is going to be the intersection of A and B, but that does not include the portion that we've already established for A, B, and RH. So let's go ahead and figure out what goes in this light green area. And we're going to do that by first looking at A and B. Which is going to be 5. So this will be our 5th step. Just so happens to be coincidental that there are 5. So we will take the 5 that we have here and we'll subtract the 4 that are already in that air region, and we'll end up with 1. So this is going to be the value that we put in right here, which will be 1. Now we need to fill in the rest of A, the rest of B, and the rest of RH. And we're going to do that by first looking at RH, which is right here. Now this will be our 6th step, and we note that there are 82 total that have the RH antigen present. But remember that we've already established that 27, 4, and 7 have the RH antigen present, so we're going to subtract those 3 values from the 82 that represents the RH. So we say 82 minus 27 minus 4 minus 7, and that's equal to 44. So we'll go ahead and put 44 right in here. Next, we're going to move further up the list, and we're going to go ahead and talk about antigen B. So this would be step number 7. Antigen B, and there are 18 total for antigen B, but we've already established that there is 1, 4, and 7 patients, so we'll take that already have the antigen B present, so we'll take the number 18, and we will subtract 1, and we'll subtract 4, and we will subtract 7 from that, which will be equal to 6. So we will go ahead and put 6 right in this area. And finally, we're going to do the part for antigen A being present, but not counting antigen B, the RH antigen, or the both B and RH being present. So this will be our 8th step. Now notice that there are 8 areas in a Venn diagram where there are 3 circles, and I have accomplished all 8 of those at this point. Now there are 49 patients that have the A antigen that are present, but as I've said previously, we've already accounted for some of the patients. So it would be 49 minus 27 minus 4 minus 7, which will be equal to 11. And we will put that value right there. And now we have completed our table. And so going ahead and determining how many A positive patients we have. So 49 minus 27 minus 4 minus 7 will be equal to 17. And we'll go ahead and write that down here and also in this circle. Now, if we add all these values up, all 8 of these, we will determine how many samples were taken, and we can determine exactly how many people had certain blood types. So the total number of samples will simply be equal to 17 plus 1 plus 6 plus 27 plus 4 plus 7 plus 44 plus 12, and that will be equal to 118. Alright, and now we need to answer these 8 questions, A through H. First, A, how many samples were represented? Well, we've actually already done that when I totaled this up previously, and that would be 118. Next, how many had exactly one antigen? Exactly one antigen would be those that were either just A, just B, or just RH. And then if I add those together, we would end up with 67. Then we have how many had exactly 2 antigens. That would be this area right here because that has A and RH. This area right here because that has A and B. And this area right here because that has B and RH. And we add those 3 values together and we will end up with a value of 35. Now, how many had O positive blood? Now, O means that there are no A and no B antigens, but the RH antigen is present. So that would be this right here, which would be 44. So 44 samples were O positive. The next question, how many had AB positive blood? Remember that I said previously that meant that they would have the A antigen, the B antigen, and the RH antigen present, and that would be this center intersection, or 4 samples. Then how many had B negative blood? That means that they had the B antigen, did not have the A antigen, did not have the RH antigen, so that would be this value right here, and that would be 6 samples. Part G states how many had O negative blood. Now remember, O negative is that there are no A, no B, and no RH. In other words, everything that is outside of the 3 circles. So therefore, we're looking at 12 samples RO negative. And then finally, how many had A positive blood? That means that they have both the A and the RH antigens present, but no B antigens. So that would be this area, and we would have an answer of 27 samples.